We are part 2 of lecture 1 on government spending and taxes. We just put in the tax column there. It's a constant $1,000 billion all the way down. Then your disposable income is Y minus T. It's income after taxes, and so we have $2,000 billion of income. The government takes 1,000. We're left with 1,000. $3,000 billion. Again, our tax amount doesn't change, except I can't have trouble subtracting. And so our disposable income will be $1,000 billion less than our total income. Again, the tax numbers should be higher down here in the real world, and these numbers therefore will not be linear in the way they're going up each time by 1,000. But again, it makes it a lot easier for us to model it that way. And our consumption is based on your disposable income, not your total. We don't get $2,000 billion as consumers. We get 1,000 because the government has taken 1,000. So what number goes there? Well, we're not starting at 0. We're starting at 1,000 this time. So we can't just put the autonomous consumption there. It would actually be when disposable income is 0. So let's go down to the consumption equation and just put in our constants. So we know that our autonomous consumption up here is 500. And then the MPC is 0.75 times our disposable income. Let's find out what it is when income is 1,000. So 0.75 times 1,000 is 750. These are billions of dollars plus 500, and that'll be 1,250. B for billions, and that goes right up here. 1,250. Now what I could do is I could use this equation to figure out each one of these numbers here, but because I know what's gone, I know that it's linear. Every time I get another $1,000 of income, it's going to add 75% of that to the previous number. And some of these numbers is going to go up by $750. And so instead of just using that equation, add 750 to that, $750, that'd be 2,000. And so I'll just add $750 billion to each one of these numbers. And I'm double checking with ones I did earlier, and those ones look correct. And then my savings will be now my disposable income minus consumption. So here I have $1,000 billion of disposable income. I spent 1,250. I'm spending more than my disposable income. That's negative savings. Here they're equal. Here I'm adding 250. Here I add 500. So that means that every time I get another $1,000 of income, $1,000 billion, we're going to increase our savings by $250 billion. And that means our MPS is 0.25, which makes sense because our MPC is 0.75. And then investment is a constant, is given to us, or I gave it, and that is $250 billion. So in our model, we just put 250 here all the way down. Same for G, government spending. That's a constant 1,250. If you would go to a major university, Federal Reserve, Congressional Budget Office, they have their economic models, and they would start with something like this, a simple version, and then they would make it more advanced, more complex, but more advanced and more realistic. And so they would have equations for, say, investment, equations for taxation, just like we have an equation for consumption. They would actually have equations for investment, government spending, taxes, to make it more realistic, but it makes it more complex. Instead of just adding in constants in my equation, I would have to add in equations to other equations, and that makes, again, them much more difficult. You would have essentially a set of different equations, and you would solve for equilibrium that way. And you can model what would happen to interest rates, how it would affect the model in terms of consumption and investment, and so forth. And the last one is aggregate expenditures, which is aggregate expenditures, C plus I plus G. And so you take the 1,250, add the 250, add the 1,250. And so that would be 2,500, 2,750. Add the 2,000 consumption, 250 investment, 1,250. What I'm doing, actually, you can add these two numbers together. My investment and government spending combined would be 1,500. Add that to each one of these consumption numbers. Or also, if you think about it going down this way, the only number that changes, because the only variable that has its own equation is consumption, and that tells us consumption is going to go up each time by 750, so it works the same way. This goes, if you go down the consumption column, each number is 750 more than the previous one. Same thing here. That would not be the case if we had a series of equations for I and G, but we don't for this simple model. What we're doing in this class is that we're trying to understand the macroeconomy and not get bogged down in the massive complexities of very elaborate economic models. Double checking with what I did earlier, and it looks like it's okay. And now can we find equilibrium? Some students go to the disposable income column, but it's not. The definition of equilibrium is not disposable income being equal to aggregate expenditures. It's our total income, Y. So this column here, you're going to compare to that column there. So if income is 2,000, aggregate expenditures is more. That's not equilibrium. They're not equal. 3,000, 3,500, not equal. Right there. Equilibrium will take place at $5,000 billion. Just to confirm that, go to 6,000. So if you go above 5,000, our aggregate expenditures is going to be less than our income. And if you go below 5,000, our aggregate expenditures is going to be greater than income. Only place it's equal is right here. That's where income is equal to aggregate expenditures. And so then I would say that my equilibrium income is equal to $5,000 billion. So that's how we model in our taxes and government spending. We can also find equilibrium looking at the leakage injection approach. So we have two leakages in the system. We have savings and taxation, that's money leaving. And the money being injected in is going to be investment and government spending. So aggregate expenditures is equal to these three categories. Your income is now going three places: consumption and savings, and that would be from disposable income, and then also taxes. So equilibrium is when AE is equal to Y. Well, this is aggregate expenditures. Equal to Y, which is C plus S plus T. So again, this is aggregate expenditures over here. This is Y over there. We can subtract consumption on both sides, and what's left? Investment and government spending on the left side, savings and taxation on the right side. So where those numbers are also equal is also equilibrium. Let's go and confirm that. So G plus I is going to be 1,500. G. and those are constants. Your savings is not a constant, and so it's not going to be the same number all the way down. So we want to find the spot where our savings and taxes is also equal to 1,500. And so here's my taxes are 1,000, so I need to have $500 billion for savings, and that'd be right here. So 1,500 taxes and savings is equal to 1,500 government spending and investment. And the only place that happens again is at $5,000 billion. So that would confirm, I'm sorry I had that too low for you, I'm sorry, bring it up. So here again, so this confirms that equilibrium is at $5,000 billion. Again, this is your aggregate expenditures, C plus I plus G, and income is now these three categories. I took away consumption, I was left with IG equal to ST, and then we went and found where they're equal. G and I is always this number. They're two constants. S and T are not because S is not a constant. But the only place they're equal again is at 1,500, and that takes place at $5,000 billion. I'll stop there and come back and do find the solution again using equations, just algebra.